The rapid expansion of progressive solutions in the world is daunting. Organ printing, computer supervision, antibiosis capsules, and underskin microchips. All these technologies were a part of sci-fi stories a decade ago. Yet they are real nowadays. How close are we to a new technological revolution? Our today's topic is scientific achievements that will dramatically change the world very soon. Technology with no unanimous attitude turns our reality already. The recent possibility of microchip implanting caused many skeptic concerns, claiming it would put an end to privacy and personal data safety. These worries are not common for Swedish people who undergo the popular procedure. They believe that the conveniences it brings fully compensate its dubious risks. NFC ferrite core chips with armature winding and a tiny micro scheme are implanted with a big syringe with a thick needle, and their average size is 2 by 12 millimeters or 0.8 by 0.5 inches. By the way, you've probably seen NFC chips absolutely everywhere. You have one in your cell phone right now, or you pay with it using Google or Apple Pay. So the benefit of having this chip under the skin is obvious. You can collect all your personal data and provide it just waving your hand. NGC biocapsule implanting is gaining great popularity nowadays. A specific tiny XNT chip made of biocompatible glass and supporting NFC can be put in a human body without negative consequences, and it can be operated by any NFC-equipped device without any additional gadgets. Another amazing fact is that you can turn into a cyborg just for $99. Besides, the kit is supplied with a specific syringe, so anyone can make themselves a cyborg anytime they wish. Artificial intelligence studies include a whole section titled Computer Vision. It entrains a machine to understand and specifically interpret the visual world around. The first researches in this field were conducted in the 50s of the previous century. At the same time, the American neurophysiologist Frank Rosenblatt invented the mathematical model of perception. Basically, it was the first model of an artificial neurotic network, so Rosenblatt methods are applied today as well. Then the algorithm was trained to distinguish between two types of simple shapes, squares and circles. At present, computer vision made a huge leap ahead and can recognize human faces with 99% accuracy. The reason for its high interest in the field: new equipment, calculation capacities, and algorithms. With due development, this technology users will witness real results in multiple branches. From recognizing faces to handling traffic or football match movement, the program excels visual human capabilities in all aspects. Automobile vision is another promising branch. Analysts state that the automobile industry makes 23% of the computer vision market in Europe. At present, it is applied in autopilot and line distinguishing technologies, so it's no wonder that they started to use similar algorithms in vehicles proper with time, not only at manufacturing stages. In the future, the 5th-generation vehicles will be autonomous, relying on the flawless accuracy of their computer eyes. Returning to the topic of vision, what do you think? What can a blind person see? The task is obviously paradoxical, nothing as they are blind. But this is far from true. Most officially blind people can see light and object silhouettes and can find their way. It means that signals from the eyes are still transmitted to the brain, and when just theoretically stimulating the retina and optic cortex, a person can regain their eyesight. Bionic eyes are designed with this very aim. Their mechanism imitates real processes of transmitting correct electrical impulses from eyes to the brain. Speaking more scientifically, the task of an electronic eye is to help people with poor eyesight due to retina or optic nerve issues. The implanted devices are supposed to replace millions of photoreception cells, even if not by 100%. Startups like Bionic Eye and Argus are already changing the lives of blind people for the better. French scientists from Pixium Vision tested the Bionic Eye in a group of volunteers. With a chip and specific eyeglasses transmitting signals to the optic nerve, the patients were able to read again. Grigory Ulanov, who became blind over 20 years ago, was the first person in Russia to get the Bionic Eye Argus 2. It is pleasant to consider that this is a very simple thing for modern medical care. The surgery duration does not exceed 2 hours. Answering the question, how to protect the human body in a long spaceflight, sci-fi fans will unanimously state Anabiosis. Indeed, the world cinema flaunts diverse cryo-capsules images and other devices that allow protecting the human body for a long time. However, how distant are we from cinema fantasies, and do these methods apply in space? The medical researcher John Bradford, president of the U.S. company Spacework, developed space technologies. In particular, methods bringing the human body into the anabiosis state during long-term flights in our galaxy. His team is successfully practicing the method of therapeutic hypothermia as early as today, when the body is slowly chilled to the temperature of 32 to 34 degrees Celsius, or 90 to 93 degrees Fahrenheit, for about 1 Celsius or 33 Fahrenheit per hour. This slows down the heartbeats and reduces blood pressure. The approach gives doctors more time to tackle complicated heart and brain issues. Bradford believes that this technology allows chilling down human bodies even more. Medical equipment used for therapeutic hypothermia can be easily reset for automatic mode and employed during spaceflights. Actually, similar experiments were also carried out by doctors from Maryland University, but not due to surgery necessity. They put a patient to anabiosis basically for the first time ever, in the direct meaning of the word. His body was chilled down to 15 Celsius or 59 degrees Fahrenheit, and the body fluids were partially replaced with the physical solution. The brain activity almost stopped functioning in this case. This allowed making surgery to a person who would change the surgery table immediately for a morgue in other circumstances. So the technology prospects are the brightest. Putting a person to anabiosis will not only allow scientists to save time during emergency surgeries, but will be a crucial point in the transportation of people in space. Great, suppose it is clear now how to protect your body in the future now. But what if there is nothing to protect? Say, some limbs or organs were tragically lost. Future medicine can tackle this issue as well. 3D printing that gained extreme popularity several years ago conquers the next peak: medicine. It allows working with biological material. To support these needs, British scientists from Osteofab created a highly durable polymeric substance that can compete with human bones in its characteristics. An implant replaced the skull section in a USA patient, and the implant repeated its unique geometry. Now, 75% of the patient's skull consists of the Osteofab material. The process becomes more complicated when the skin printing is in question, as it is difficult to reproduce the required tone, customizing it for a certain person. But the scientist James Yu is already designing a machine able to print immediately on fire survivors. Liverpool University researchers plan to create a base of skin samples with scan pieces available for remote hospitals. As of now, scientists can reproduce face parts such as noses and ears, as well as the skin, bones, organs, and even eye prostheses. The least studied branch is the printing of the blood circulation system. Some of its segments are too complicated and tiny, and thus not available for most 3D printers. Nevertheless, Germany is developing this technology now, even though the technology is animal tested only. This system is far too imperfect yet to provide material suitable for humans. Even the process seems daunting at times, it can be hardly stopped. Human minds invent hundreds of thousands of amazing things. And how do you envision future technologies? Can flying cars, cryocapsules, and 3D printed ears fit there? Please share your opinion in the comments, and don't forget to subscribe to our channel.